Pom. We have up till now focused on arithmetic and algebraic expressions. An arithmetic expression has numbers and operations, like here, and an algebraic expression also has variables, like here. The value of an arithmetic or algebraic expression is a real number. For example, the value of this expression here is 4 divided by 13. If we have an algebraic expression, then the value may depends on the variables there, values. If we have an algebraic expression, then the value depends on the values of the variables. So, for example, here, when x equals 3, the value of this expression here is 4 divided by 13. But if x equals 10, the value of this expression here is equal to 80 divided by 30. Now we're going to introduce a new kind of expressions, logical expressions. Logical expressions express something about the values. And a logical expression adds relations to the standard algebraic expressions. So, for example, here we have a relation which says that 2 times 3 minus 1 divided by 13 is less than 1. And in this case, this is true because we know that the value of this algebraic expression is 4 divided by 13, which certainly is less than 1. So we then say that the value of this expression is true, and we write the value as t, capital T here. So the value of a logical expression is a truth value, either true T or false, capital F. And again, the value of a logical expression may depend on the values given to the variables. So, for example, when x equals 3, then the value of this logical expression is true, as we stated above. But when the value of x is 10, then this algebraic expression has value 18 divided by 13, which is greater than 1. So it is false that it's smaller than 1. So the value is then false here. So altogether, we have in summary, we are now introducing a new. So a logical expression can thus have two values, true and false, which are called truth values. And the truth values form a new domain called B, capital B, or kind of blackboard B. B called B, which only has two elements, true and false. The notation B for the truth values comes from the 19th century mathematician George Boole, who was one of the pioneers in mathematical logic.